Hey yo, welcome back to Math Party people. Anderson here, your math coach, and in this video we're going to go over Competency 2 of the FTCE GK Math Practice Test that's available on the state website that you can go ahead and grab for yourself and try out. We put the link in the description of this video, but the purpose of this video is to help you stress less and understand how these questions are formulated and the best practices to make sure that you succeed at the end of the day. So with that said, let's go ahead and get started. And don't forget, if you want us to produce more content for FTCE, for your test, then go ahead and make sure that you're subscribed to the channel, comment on every single FTCE video. That way we can make sure that we see that the demand is there. With more demand, that pushes us to put you guys as a priority over the other tests like Praxis or Texas or GACE. That way, again, you get all the attention. So here we go. Let's have some fun, my party people, starting with Competency 2. And go ahead and check over here somewhere for the link to part 1 where I went over Competency 1. So let's go and get into it, my party people. A building 51 feet tall. Blah, 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 blah. Why am I stopping? Well, for the simple reason being this. Every time we're doing a word problem, it's always best to actually start off with the question sentence itself. Because the question sentence answers the question, what the heck are we doing here? You know, we want to know what we're supposed to be doing before we start being thrown information and get confused and blank out on word problems, right? We hate that. We don't want that. What we do want is to be calm, cool, and collected and look at a question without any hesitation. So, first things first, right here, how tall is the statue? Okay, sounds good. So all I want to know is right here, number 1. The statue is blank, and we see the answer choices say feet. So blank feet tall. All right, cool. So with that said, now what we're going to do is we're going to collect the information and see how this is all going to be laid out. Let's see what we notice. And remember, Competency 2 is all about knowledge of geometry and measurement. That includes proportions. So let's go ahead and take a look at the information here. What do we see? It says, hey, a building 51 feet tall casts a shadow 48 feet long. So let me write that down there. So again, second step is writing down your information. And again, this building that we're talking about is 51 feet tall. And we see that it's 48, its shadow. Let me go ahead and take that away there. Now we see that the shadow is 48 feet long. Okay, cool. So again, that was the information right here. Let me go ahead and highlight that. Now next, I see that it says simultaneously, a nearby statue casts a shadow of 16 feet. That's the statue that we're talking about here. So let me actually write that down right over here. Shadow is 16 feet long. Now, why was that important? Well, I've written down all of my information. I've written everything down. Let me go ahead and just circle that right there. What do you notice? I noticed that what I'm looking for is how tall the statue is, given its shadow. And then I also have a building that is, we're given the height, which also has a shadow. What's going on here? How do I know what's going on here? Well, this is a proportion, and let me explain to you why. A proportion, the main idea that proportions follow is this. Proportions compare the same things in the same way. So write this down for yourself. Again, do yourself this favor. With proportions, again, we compare the same things in the same way. Compare the same things in the same way. Booyah. That's what we're doing with proportions. So if you notice, we have the height compared to the shadow. The height compared to the shadow. That's what we're talking about when we're comparing the same things in the same way. And the very, very simple way to get this done, my party people, is this. I'm going to say, T feet tall. So what I'm going to do is I'm going to compare the statue's height to its shadow, which will end up being right over here, T over 16, because again, this is the height, this is the shadow. Let me put this in blue. Right over there. And then over here on the right side, we need to make sure that, again, we compare the same things in the same way. And so what that means is right over here, I'm going to have to make sure that the top here still represents the height of whatever we're talking about, And then the bottom still represents the shadow of that same thing. So right here, 51 feet tall. So I'll plug that in right there. And then the shadow, 48 feet long. Boom, right there. Now that I have that set up properly, again, notice that the top is going to be the height, the bottom is the shadow, top is the height, bottom is the shadow. We have successfully compared the same things in the same way, and now we're good. We're good to go. So let's go ahead and get it done, my party people. Here we go. To solve a proportion, there's a couple of different ways you can do it. And one of the main ways is by cross multiplying and dividing. I think we've all heard of that before. And because on the GK math test, you're allowed to use a calculator, I'm going to grab my calculator here, and I'll just go ahead and cross multiply and divide, not waste time, we're good. So here we go. Bam, we'll go ahead and say, hey, t times 48, that's going to be 48t. And then we have 16 times 51. Grab your calculator, just make sure to plug the numbers in correctly, and we get 816. The last step that I'll take is then divide. So I'll divide both sides by 48, nice and easy. 816 divided by 48 is going to give me 17. T equals 17, booyah, and we are set. Answer is A. And there you have it. So far, so good, right? This first question was about a proportion. That is included in geometry and measurement, absolutely, 100%. So again, make sure that when you're doing these problems, it's not just about knowing what the right answer is. It's always going to be about growing from the question and taking something from it. A piece of knowledge or understanding that you can take with you to the next problem and the one beyond that. So let's go and take a look at the next question here. Question number 8. So here, it says a rectangular animal pen will be built using blah, 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 blah. Again, what's the first thing we do? Read the question itself, the question sentence. What are we trying to get after here? So right here it says, if one side of the rectangle is 60 meters, find the area of the pen. Okay, cool. Sounds good. So it says rectangular animal pen. I want to find the area of this. Okay, cool. So step 1, what's my question? What am I looking for? I'm looking for the area of the pen. And now here's the great thing about geometry word problems. Whenever you're dealing with a geometry word problem, 99 times out of 100, there is a formula involved. And because specifically in this question, we're looking for the area of a rectangle or rectangular pen, there's a formula to that. That area is going to be right here. Area equals length times width. Length times the width. Booyah, right there. That's the awesome thing about this. And because of that, my party people, all I have to pay attention to now is how can I get the length? How can I get the width? I have to just look at that information. That's all I care about now because I know what my formula is. I know what I have to plug into it, and then I'm done. Notice how much of a better sense of confidence we have when we know what we're supposed to be looking for before we read the information. You know, if you start reading and you say, hey, a rectangular animal pen will be built using this much fencing. Like, who cares? Why do I care about that? Oh, we're trying to find the area. Okay, that's why I care. Boom, makes things so much easier. So let's go ahead and just, when in doubt, draw this thing out. So right over here, booyah. And we see that one side of the rectangle is 60 meters. Okay, cool. So I don't know which side it's going to be. It could be this one, could be this one. I'm not sure. I don't know. So I'll just go ahead, it doesn't matter to me. I'll just go ahead and label this right here, 60 meters. Okay, now let's understand the information we have. The information we have is, again, we have one of the sides, 60 meters, but I'm still looking for the length. I'm still missing something. So what can I do here? Well, the other piece of information that I have is this. Built using 200 meters of fencing. What does that mean? That's the perimeter. That's the perimeter, everybody. Because, my party people, think about it like this. If we're saying that we're building this rectangular pen with this much fencing, what am I outlining? The border. I'm outlining the border, and the border represents the perimeter, the distance around the object. And so this is a big, 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 big hint because we are given, again, the perimeter. Now, my question is this. If I have the perimeter, how the heck am I supposed to get the area? You don't need to get straight to the area. What you need to do is find the length. We need to find the length because once I have that, everybody, I can plug in the width, plug in the length, multiply them, and I'm done. You got that? One more time. All we need to concern ourselves with is finding the missing side, the length. Once we have that, then we're good to go. So what do we know about perimeter that can potentially get us to the length? What do we know? Well, what we know is that there's a formula for perimeter. Don't believe me? Let's take a look right over here. Here's our study guide. So we have area that's given to us here for each of these shapes. Do we have perimeter? Wow, that's funny because they don't actually give you the perimeter here in your formula sheet. This is the formula sheet that's going to be available to you on test day, and they don't actually give you the strict perimeter formula, so you're going to have to actually memorize this. So here's the formula for perimeter. It's going to be perimeter equals, let me actually write this where I can have some space. Let me move this over here. So the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. How do I know that? Simple reason is this. Basically over here, notice that we have a length and a length, 2 lengths, a width and a width. That's 2 widths. That's where the perimeter comes from. 2 of the lengths plus 2 of the widths. And I know that my perimeter is 200 meters. So I'm going to plug that in right here. And then we also have, again, one side is 60 meters. So I don't know which one that's going to be, the length or the width. Doesn't matter. I'll plug it in for the width. I'll plug it in for the width. So we have 2L plus 2 times 60. And it looks like what we need to do here is solve this equation and we'll finally have our length. But don't forget, don't get too ahead of yourself, because once we have the length, then we plug it in to get the area. So here we go. 2L, 2 times 60 is 120. And then from there, we take away 120 from both sides. Booyah. And then from there, we will have ourselves left with 80 equals 2L. And then we divide both sides by 2. That's going to give me L equals 40. There is my length. I'm not done though. I'm not done. Remember, the goal is to get the area right over here. And so now that I have the length of 40, again, this is not drawn to scale by any means because obviously 40 is smaller than 60, but don't worry about that. What we need to worry about is finishing the formula for area, and that's going to be here. Area equals 40 times 60. 40 times 60 is 2,400. Booyah, 2,400 square meters, and that's going to be C as the correct answer. I'll move my big old head out of the way. That way, if you'd like to take a screenshot of this, go ahead. But so far in the video, I hope you're having a lot of fun, my party people. Go ahead, don't forget, I am building content for all teacher certification. So that includes FTCE and a lot of other tests across the nation. So if you want to see more FTCE specific content, then do yourself a favor, subscribe to the channel and comment on these specific videos. Like these videos, watch the whole video. That way, I see when I look at my data and it says, hey, people really like FTCE, I'll go ahead and produce more content for it. You know I got your back. So do me that favor so I can do you that favor. Next up, let's go ahead and check out question number 9 for Competency 2. More geometry. The question reads, which of the following geometric figures must have perpendicular diagonals? Perpendicular diagonals. Let's check it out. So what does perpendicular diagonals mean? A perpendicular diagonal is this. When you have intersecting lines, and when these lines intersect, it creates a right angle. Perpendicular means that it creates a right angle. So what we're looking for is, hey, what kind of a shape can we create that has perpendicular diagonals? You know, what kind of shape is that would allow this to take place? And so let's take a look at the choices. A says quadrilateral. What's a quadrilateral? A quadrilateral is just a 4-sided shape. Quadrilateral, 4 sides. So that could be a rectangle, that could be a parallelogram, that could be a square, that could be a rhombus, that could be a trapezoid. That's not specific enough. That's not specific enough, because think about it like this. If I had a regular rectangle, guess what? If I drew the diagonals, are these perpendicular? One second here. Are these perpendicular? No, those are not right angles. It looks like Florida's flag, but that's not perpendicular. No, this is definitely an obtuse angle. That's definitely an acute angle. No, so I know for a fact that if I'm just speaking broadly about just quadrilaterals, no, that's way too broad. That's not specific enough. And I just proved that a rectangle wouldn't work as well. Rectangle wouldn't work. Now let's take a look at a parallelogram. Okay, parallelogram. What is a parallelogram? Well, a parallelogram, my party people, is simply a shape that has two sets of parallel sides. So if I take a look, if I go ahead and do this, and then I copy this, duplicate it over here, if I can just go ahead and show it all the way like that, and then this would be parallel to this. This is a parallelogram where you can go ahead and parallel sides there, parallel sides there. And so if we take a look at the diagonals, let's go ahead and just understand these. Do these automatically create perpendicular lines? Not quite. Not quite, not quite, not quite. And I can prove it to you by turning this over like this. It may look like it's perpendicular, but remember, this is just one type of parallelogram that I can show. I can go ahead and extend the sides, and it would absolutely affect the angle that we have. So let's see if I can actually do that here. So if I went ahead and extended this a little bit over here, and then extended this a little bit over there, notice how it may absolutely change how these look. Definitely changes how it looks. And to prove a point, a rectangle is a parallelogram. Notice, these are parallel, and these are parallel. Notice we didn't have those intersecting right angles. We didn't. A rectangle is a parallelogram, and so that wouldn't work either. The only choice that we have left is a rhombus, and a rhombus is actually going to be the correct answer. Let me actually show you an example of a rhombus. A rhombus is literally like a square, except they're not straight up and sideways. You can have the parallelogram figure. So here would be a parallelogram. Let me go ahead and copy this, copy that there. Then I can duplicate it here. I'm trying to do my best to not mess it up. But this would be a rhombus, more or less. And when we go ahead and draw these diagonals, this is what you saw earlier with that parallelogram that I drew. You'll have these right angles. You'll have those right angles. You absolutely will. And one way that you can absolutely tell, and again, there's the answer, but one way you can tell that rhombus is supposed to be the answer is this. Notice that, hey, when it comes to a rectangle is a parallelogram. A rectangle is a quadrilateral. So you can get rid of A and B automatically because the rectangle is just a more specific version of these two. And the thing is, a rhombus, again, is a quadrilateral, and it is also a parallelogram. So really, the choices that you're looking at between are just rectangle and rhombus. If you know what a rectangle looks like, you can tell that a rectangle doesn't always have perpendicular intersections. So you can get rid of that, and then you can, by elimination, get D. Again, that's just one way to do it. That's just one way. So with that said, my party people, let's go ahead and keep it going here. Next up, we are taking a look here at question number 10, and it says, hey, select the geometric figure that possesses all of the following characteristics. Okay, sounds good. So here's what I'm going to do. This is a question where we're basically saying, hey, which one of these checks all these boxes? Okay, how do we do this? Well, what I'm going to do is I'm just going to go ahead and read through and look at the choices and say, hey, does this satisfy that condition or not? That's it. Watch. So let's go ahead and zoom in right here. And it says, hey, quadrilateral. Okay, quadrilateral means four sides. Okay, so which one of these has four sides? Rectangle, yep, four sides. Rhombus, four sides. Trapezoid, four sides. Triangle, no. A triangle does not have four sides. It's a triangle, three sides, not four. So automatically D is out. Next up, let's take a look here, and it says the diagonals that bisect each other. The diagonals bisect each other. What does that mean? What that means is the diagonals, when you're going inside of the lines, they cut themselves in half. So let's see what we have here. If I take a look at a rectangle, do these lines here and there, do those lines cut each other in half? The answer is yes, absolutely. This is the same length as that, and then this would be the same length as this. Truly, they're all the same because it's a rectangle, but yes, they do bisect each other. And so a rectangle so far checks that box off. And then lastly, what we're going to see here is rhombus. Well, do a rhombus's diagonals bisect each other? If I take a look at the previous example that I drew a rhombus in, yeah, they actually do as well. They actually do. This is half of this, and this is half of that. Absolutely. So a rhombus would cover that as well. A trapezoid? Not exactly. A trapezoid just means that you have only one pair of parallel lines. So honestly, like this could be a trapezoid right here. This is technically a trapezoid, and they do not intersect each other in a way that bisects those diagonals. So if I go ahead and draw from vertex to vertex, from here to there, notice that this is much smaller than that. So with a trapezoid, it's not guaranteed, and therefore I can cross that out. Trapezoid wouldn't fit the bill there. Lastly, at least one right angle, that's a rectangle all the way. A rhombus can have a right angle if it's in the form of a square, because a square is a rhombus, but it's not always going to be in the form of a square. That's why it's called a rhombus. And so therefore, answer A is correct. It is going to be a rectangle. It fits all three, and you're good. Another way to get this one done is just going down each choice and then going through all three characteristics. You could do that as well. So next up, let's take a look at question number 11. So number 11 here. Which of the following best describes the faces for the following figure? This one is about understanding 3D shapes. So let me show you what we're looking at here. What we're looking at here is we're looking at a triangular prism. We are looking at a triangular prism. And here's how we're going to take a look at this. So let me just copy this line right here. And what I'm going to do is I'm going to just move this over here. And then what I'll also do is I'll also go ahead and take the line from here to there, move that over, and then I'll go ahead and connect this lastly from here to here. And then just to make it a little better in terms of, just being able to see it, I'll show you that this is, the inside of the shape. That way it's a little easier on the eyes. But boom, look at that. It looks a little better, right? So what I want you to see is that we have a triangle at the face here and a triangle in the back there. So we have two triangles. And then we have how many of these rectangles? Well, we see that we have one here on the really, really big face that we have pointing to us. Then we have another one over here in the back and another one over here at the bottom. So that's three rectangles. Three rectangles. Cool. And there we have it. And we're good. So my math party people, what do we have here? So it says, hey, which of the following best describes this? Well, I see that we have, two equilateral triangles. What do you mean equilateral? Then we have two isosceles. Which one is that going to be? Which one is that going to be? Well, when you take a look here, we see that we have a 45-degree angle here, a 45-degree angle here, which means that we have the same angles. If we have two angles that are the same in a triangle, that means we have two sides that are the same. Two sides that are the same, that constitutes an isosceles triangle. And so we can go ahead and take away the equilateral parts because that is not true. That is not true. We do not have equilateral triangles. They are isosceles, and we have two of them. So now we're taking a look at these last two options, and we're seeing that we have one square with two rectangles or two squares with one rectangle. Which one is that gonna be? Well, here's the clue that we can use. The clue that we can use is from, again, the angles that were given. Notice that this is 45 degrees. So this right over here, this side is going to be the same as this side over here. I know that one of them is labeled B and the other one is labeled A, but the fact of the matter is that those are actually going to be the same side. They're the same. And notice how we're labeling this as A as well. So what does that mean? That means that if this is A and this is A, well, guess what? That's a square, because this side and that side and that side and that side are all going to be the same. So that's absolutely going to be a square. And if you look over here, well, guess what, my party people? If this is B, which is, again, the same thing as A, the same exact thing like we proved, that means that this side and this side and this side and this side, all going to be the same. So we have two squares. And then C is the hypotenuse, that's the long side. And so we have a really, really, really long side. Let me take care of all of this over here. 1 second. Okay, so what we have here is going to be, this is going to be the side length A or B or whichever one you want to call it. But then you have C all the way down here. That is absolutely going to be a rectangle. So you have two squares and a rectangle, making the answer here D. So you definitely got to know your geometry here. Absolutely got to know your geometry. That way you can take a look at these figures and say, okay, yeah, that's exactly what that is. Okay, so let's keep it going here, my party people. Are we still in Competency 2? We absolutely are. We have 1, 2, 3, 4, 5, 6. We have 6 more to go, and we are set. So let's go ahead and get into question number 12 here. Let's keep it going with Competency 2. We got this. So which of the following is the best estimate for the height of a kitchen refrigerator? Okay, so this is about, in Competency 2, your ability to estimate or reasonably estimate the heights of objects or the size of objects. So let's think about a fridge. If we take a look at the answer choices, well, here's the thing. Let me use red here. Is a fridge going to be 2 millimeters? A millimeter is honestly super, super small. If I were to grab my ruler, that's going to be 1 tick right up here. Is that a fridge? Absolutely not. Like, let's not kid ourselves. You got to know what a millimeter is. No, not going to be A. Next answer, 2 centimeters. Okay, so 10 millimeters is a centimeter. So, okay, that's going to be 2 centimeters right there. Is that a fridge? No, of course not. Of course not. That's not going to be it. Then C, 2 meters. This is not even a meter. A meter is about a yard. So let's think like from here to here. And I'm not even on screen anymore. So if you have 2 of those standing up, that's like saying, let's say you have a basketball player. That's about 2 meters. Do you think a fridge could be the size of a basketball player? Absolutely. Absolutely. That's going to be the answer. Now, do you think a refrigerator is 2 kilometers? 2 kilometers? Are you serious? 2 kilometers is maybe somewhere around 1.5 miles. Obviously, refrigerators are not made to be 1.5 miles long. I don't even know if one such type exists. And so with that, that's going to be gone right there. The answer will be C, as we've shown right there. So again, this is a problem about reasonable estimation. You got to be prepared for these types of questions for sure. Next up, let's take a look at number 13 here. Lucky number 13. Which of the following is the best estimate for the height of a mountain? Ooh, okay. Just like we saw in the previous question, 4 centimeters? No. 4 meters? So 2 basketball players? No. 4 kilometers? That seems pretty reasonable. That seems very reasonable. 4 millimeters? No. So by process of elimination, we can get rid of these crazy answers, and we can get to the reasonable one right there with C. Nice and easy. Next up, let's take a look at number 14 here. Oh, I love this one. Number 14. How many square yards of carpet are needed to completely cover a rectangular floor that measures 15 feet by 9 feet? So it says again, how many what? How many square yards? But notice that this says 15 feet by 9 feet. What's the problem with that? The problem, simply put, is that you have to convert the units before you actually multiply. That's the trick here. So with that said, my math party people, 15 feet by 9 feet, to convert this, well, 15 feet To convert it to yards, remember that every pair or every group of 3 feet is 1 yard. So we need to see how many groups of those 3 feet fit into 15, because that'll tell us how many yards we have. So I divide 15 feet by 3, and that's going to give me 5 yards. And then if I go ahead and do 9 feet divided by 3, that's going to give me 3 yards. So what I have now is 5 yards by 3 yards. And if I multiply 5 yards by 3 yards, that's going to give me 15 square yards. Now, the biggest trick to this question, the common mistake that a lot of people make, is that they'll first try to multiply the 15 times 9. And once you have the 15 times 9, that's going to be 135 square feet. And then people will believe that, okay, I have 135 square feet. Let me divide by 3 to convert it to yards. But that's a mistake, because it's going to be square feet. So if you're converting a square unit, you need to do the square of the conversion. So instead of dividing by 3, you should divide by 9 to go from 135 back to 15. Again, common mistake, not so common solution, but we do need to be very, very aware of how to convert units, square units, and cubic units. Okay? So let's keep it going here, my party people. If you're enjoying this, again, let me know in the comments section. I really want to know if you're enjoying yourself, because that'll help me make more content for you. Here we go. Next question here. Read the question first. What is the cost of the wood for the deck? Cool. What is the cost of the wood for the deck? So what I'm going to do here is I'm flat out going to go ahead and understand. I'm looking for a cost. I'm looking for a dollar amount. And I'm going to read the information that I'm given for the only purpose of understanding the cost of this wooden deck. And again, remember, if you want to try the problem out yourself before I go over it, pause the video and then we'll go over it together. So here we go. It says, hey, a 3-foot wide deck will be built around a rectangular shaped pool that measures 15 feet by 30 feet. The resulting shape is also rectangular if the lumber costs $10 per square yard. Pay attention, don't get tricked. 3 foot wide, 15 feet by 30 feet, and then we have yards there. Don't get tricked. Do not get tricked. Here's how we're going to take care of this, my party people. Let's go ahead and draw this out. So here's the rectangular shaped pool, 15 feet by 30 feet. If I draw this out, right over here, booyah, and I'll just do it like that. And we'll say that this is, again, 15 feet by 30 feet. The first thing that I really noticed that alarmed me was that we're looking at the cost in terms of square yards. So what I need to understand is this. If I'm going to be solving this, it's best to keep it all in the same units. Since we're going to be doing the cost in square yards, I am going to go ahead and say, hey, let's turn all these feet measurements into yards. So how do I do that again? Just like in the previous question, there's 3 feet in 1 yard. And if you forgot about that, remember to use your guide here. This is available to you during the test. And you see here, 1 yard is 3 feet. So you have that there, right there, ready for you. Take advantage of that. Make sure you're not confusing yourself. So 15 feet, if we divide that by 3, that's going to be what? 5 yards. So I'm going to just erase this right over here. And that's going to be 5 yards. And then 30 feet, if I divide that by 3, that's going to be 10 yards. Okay, cool. So then, what else do I know? Well, it says, again, a 3 foot wide deck will be built around it. So let's go ahead and do that. Let me move this to the inside, just in case I need that space. So I'll use green here to draw that around. Booyah. And so I can go ahead and kind of just do it like this. Cool. And so what this means is that, hey, we have an extra 3 feet here. But remember, 3 feet, what is that? 1 yard. Again, turn it straight up into yards immediately. We have 1 yard extra here on this side, 1 yard on that side, 1 yard here, and 1 yard here. So there's our border that we're looking at. And then it says the lumber costs, let's write that down, $10 per square yard. So what we're going to be doing is if it's $10 per square yard, we're going to multiply it by the number of square yards we have. Because again, if it says per square yards, well then we're going to go ahead and multiply by the amount of square yards we have, and that's going to give us the total cost. That's the straight up version of it. The confusing part is, hey, converting all these units. That's the confusing part. So with that said, my party people, let's make it simple. Let's have a good time here. The way that we're going to do this is by noticing that if we're looking for the cost of the wood for the deck, the wood is the border. The wood is not the pool itself. Again, this is the pool. This is the pool. This is the water. This is our border here that we're looking at. That's what we want. So how are we supposed to find that? Well, one easy way is to do this. Let's find the entire area of everything and then just subtract the area of the pool. If we take out the area of the pool, that's going to allow us to only be left with the border. So let's find the area of the pool itself. That's going to be 5 times 10. So 5 times 10, that's 50 square yards. Now, if we look at the entire pool area with the wood itself, well, what do we have? If this was 5, we have 1 yard there, so that's 6, and that's 7. So this is 7 yards. And then over here we have 10, but then we have 11 and 12. A little neat trick, right? It's not really a trick. It's just understanding how this is set up in terms of the diagram. So we have 7 by 12, so the whole thing, so the entirety is 7 times 12, which is going to end up being 84 square yards. So with that said, we're going to take away the 50 square yards that we have right there, and that's going to give us 34 square yards. So how are we going to use that information? Like we said, that 34 square yards, this right here, only covers the border right there. So now that we have that area that we're looking for, now we're going to multiply that area by the cost per area, and now we're set. So here we go. 10 per square yards times 34. That's going to end up being $340. Nice and easy. Booyah! And that's answer choice C. I know that one was a little crazier, for sure. I know that was a little crazier, but I'm glad that we were able to go through this one and understand that there's a lot that we are potentially being asked to do, especially in problems like this. Let's go and take a look at the next one here. So we have this one, 2. Cool. We have 2 more here for competency 2. Let's go ahead and keep having fun, man. And again, don't forget, comment if you enjoyed some of these solutions. Which one did you enjoy? The question numbers are right up there. Go ahead, let me know which ones you enjoyed, which ones you would like me to try again, maybe do them in a better sense. That way I can help you get better. So here we go. First things first, how many square inches of wrapping paper were left over? Again, read the question first. How many square inches of wrapping paper were left over? Left over. If you look at that right there, that key phrase, basically it sounds like we're saying we're going to have a total amount and the amount that we used, and it sounds like we're going to be subtracting to find out what's left over. Does that make sense to you? Because it should. It should, for the simple reason being that that key phrase left over, in terms of just an intuitive sense, that really is going to be saying, hey, we're going to have a total. We take some away. We got some left. We can think about it in a nice intuitive fashion, just like that. So again, finding the leftover, it sounds like we're going to be taking the difference of 2 amounts. And it says how many square inches. So it sounds like area. Square units is always going to be area. So the difference of the areas. All right, let's take a look at the information we have. Let's work through this and let's see what we can write down. So I hear it says, hey, a teacher covered the exterior of a rectangular prism-shaped box. Okay. And it measured 8 by 9 by 10 inches. And what we used here was 1 sheet of a rectangular shaped wrapping paper that was 2 by 3. Okay. There were no gaps or overlapping paper. How many square inches of wrapping paper were left over? First thing that I see here is that we have a rectangular prism. So we can go ahead and draw it like this. So we have this present that we're trying to wrap right there. Yes, I like drawing, of course. So we have this going on. So, and it looks something to that effect, right? Looks something to that effect. I'm just kind of help you visualize this right there. So we're trying to wrap that present, and we're given a 2 by 3 feet piece of wrapping paper. Okay, cool. So the wrapping paper that we're using is 2 by 3 feet. But notice what the question says. Again, you got to pay attention to these little details. How many square inches? That's the biggest thing there. So what are we supposed to do? Well, turn everything into inches. Turn everything into inches first, and then do yourself the favor of finding out the area of the box, which is going to be called surface area, and then finding the area here and subtracting. Let's go and get it done. So 2 feet, if we convert it into inches, is 24 inches. 3 feet is going to be 36 inches. Now, if we calculate that area here that we have for the wrapping paper, again, this right here is the wrapping paper. If we take the area, let's go and do it. Grab a calculator, blah, blah, blah. And what I'll do here is I'll say 24 times 36. Booyah, that's going to be 864 square inches. So that's how much wrapping paper we have to work with. So that's what I'll write down right here, 864 square inches. And I'm going to subtract the area of the present. So the present is right here. There's the present. And the present is told to be 8 by 9 by 10. So I'll say this is, 8 by 9 by 10. So the main question at this point, again, these are inches. The main question that a lot of people might have at this point is, well, hey, Anderson, how do you find the area of a 3D object? This is called surface area. And the way that we're going to find surface area is literally going to be similar to how we do perimeter, but just pay attention here. And if we look at our study guide, do we have it here? Well, let's see. Oh yeah, we do. Boom. Surface area of a prism or pyramid equals the sum of the areas of all the faces. Nice. Cool. Find the area of all the faces added together. That's exactly what I'll do. So the area of the front face, that's going to be 8 by 10. And remember that there are 2 of those. There's one here at the front, and there's another right there at the back. There's 2 of them. So my surface area is going to be equal to, we're going to have 2 times 8 times 10 plus 2 of these sides here, the left and the right sides together. That's going to be 2 times 9 times 10. Then we have 2 of the top and the bottom. We have 8 by 9 right here, 8 by 9 right there. Boom. So I know that seems a little crazy, but it's a very simple, straightforward formula. It's literally going to be basically mix and match all of the different sides, multiplying. 8 times 10, 9 times 10, 8 times 9, multiply each of them by 2, because there's 2 of sides of each. So 8 times 10 is 80, times 2 is 160. 9 times 10 is 90, times 2 is 180. 8 times 9 is 72, times 2 is 144. Add all of these together. You can use your calculator, or you can go ahead and use some mental math if you'd like to. Either way, that's going to end up being 340, and then that's going to be 488. Let's double check that. Yep. Excuse me there. It looks like I made a mistake here. 160. Look at how I make a mistake using the calculator, but not with mental math. And so from there, 144. Yep, 484. So booyah, we've got that. 484. And that's what I'm going to be subtracting. That's the surface area of my present box there. And when I do the math, we have 864. And we're going to go ahead and take away 484. And that's going to give me 320. So there are 380 square inches of wrapping paper left over. And there we have it. Booyah, and we're good. Answer here is B, just like that. Let's go. So again, take a second to pause, take a screenshot if you need to. Go ahead and comment. You can comment more than one time on a YouTube video. There's nothing illegal about that. And shout it out. Shout out the questions that you learned something from and the questions that were still a little confusing for you. Go ahead, ask away. I got you. So let's take a look at this last one here for Competency 2. And then remember, I'm going to be filming Competencies 3 and 4 in different videos. That way, this is not just one really long video. I got you. So here we go. This is the last one. First things first, go to the question. We see here that it says, what is the volume of air in the building in cubic feet? Always pay attention to the units. Always pay attention. Cubic feet. Okay, great. Do I notice anything weird? Well, if I read quickly, a building contractor needs to compute the volume of air contained in a building with a rectangular floor, as shown in the figure below. The building is 20 feet long, okay, 4 yards wide. I don't like that at all. Let me convert that right now. 4 yards, that's 12 feet. Right here, this 4 yards right there, that's 12 feet. I am not going to put myself in a position to get confused. No, sir, no, sir, no, sir. They want cubic feet, so I'm going to do everything in feet. Then it says 9.5 feet high right there on 2 sides and 15 feet high from the center to the top. What's the volume in cubic feet? Okay, great. So here's how we're going to get this done. To find volume, well, what we're going to do is we're going to go ahead and separate this into 2 shapes. Here are the 2 shapes that I'm going to separate this into. Notice that over here, if I split this right there, what I have is a triangular prism up top, and then I have a rectangular prism on the bottom. And there we go. So splitting it up like this, and for my OCD folks, let me go ahead and just kind of cover this up, leave a little bit of space so I can make you guys mad, but there we go. So we essentially have this top triangular prism and this bottom rectangular prism. All I need to do is go ahead and find the volume of each and then add them together. That's it. That is it. Now, when we take a look at the blue here, so I'm going to do red and blue. So if I'm doing the blue, the rectangular prism, that volume is going to be equal to the length times width times height. That's going to be pretty straightforward. The length is 12 feet. The width is 20. The height is 9.5 or 9.5. Don't worry about decimals. You have a calculator, no need to worry. So if I go ahead and just do that volume right there, grab your calculator, we have 12 times 20, which is going to be 240. And then we're going to go ahead and multiply that by 9.5, 2,280 cubic feet. So right here, boom. Now over in the red, so we're going to be looking at the triangular prism part. Remember that the volume of any prism is going to be the area of the base multiplied by the depth or the height. So that's why we simply, for the rectangular one, we just did all 3 of these multiplied together. For the triangle, we have to find the area of the triangle in the front and then multiply it by the height or the depth in this case. So the depth is going to be, okay, so the area of base times the height. Again, the height or the depth, they both mean the same thing. So the height in this case is going to be the 20. But what's the area of the triangle? Well, remember, the area of a triangle is going to be half of the base times the height. So my base, let me actually just give you a little bit more of a vision here. Boom. So we need to understand that we have to find the base, the height, and then we cut it in half. The only little issue is that we don't know exactly what this is, for the only reason being that we have the entirety 15, we have this is 9.5. So that means that this is 9.5, and if we take it away from 15, we'll have what's left. So what's that going to be, my party people? So 15 minus 9.5 is 5.5 or 5.5. So let's go ahead and write that down. From here to here, that's going to be 5.5 feet. The actual base is still going to be the same, the 12 right here. So we have what we need. We're going to have the area is going to be 12, which is the base, times the height, which is 5.5, all of that divided by 2. I know it seems like a lot of math, but we need to practice our ability to find volume of triangular prisms and rectangular prisms. We have to make sure we get this done. We got to make sure we practice it. So 12 times 5.5 divided by 2 times 20. That's going to give us 660. Boom. 660, and that's going to be cubic feet. So now that we have everything we need, we'll take the 660, we'll add it to the 2280, and that's going to give us 2940 right there. So the volume, total volume, right here, my party people, is going to be 2940 cubic feet. And that will be answer choice C. Booyah! And we are done. Let me zoom on out for you. That way you can go ahead and take a picture of the work if you need to. But there it is, my math party people. That is the end of competency 2. And as always, again, I really hope that you enjoyed this. You know, I know that you're wanting to get into the classroom and teach kids as a permanent licensed teacher. And I've been there before. You know, I am a licensed teacher as well. And, you know, I want to help you help the kids. So with that, I appreciate you guys. Keep fighting for this. I know it's not the easiest thing in the world, but I know a lot of you have the energy and the will to do it, and I'm hoping that I can give you the know-how to get it done. So with that said, my math party people, love y'all. If you wouldn't mind, again, if you want to see more FTCE content specifically, then make sure to like this video, comment on it, and subscribe to the channel, because I am doing more than just the FTCE. But by demand, I will be looking at what's more popular, what people want me to do, and I will push out that content for you. So with that said, I hope you are looking forward to part 3, where we're going to be continuing on to going over part 3, competency 3 of this practice test. I'll see you, my math party people. Let's keep raising